Hello guys, welcome to the 10th episode of Trying to Learn C. In case you don't know what is going on, I am trying to learn C, and how I intend on doing that is by programming some 50 programs I got from ChatGPT. Currently I've done 15. I am on the 16th one. Last episode, on episode 9, I started this. I did bubble sort fine, but then I had a bit of problem with selection sort, and I was able to do it in the end, but I want to retry it, then go into insertion sort. So I think some of the main problems I faced last time in selection sorts was that I was visualizing everything in my head. So and that was not it. So how I am going to tackle that problem was I found this Escalidro, I found this website. So whenever it comes to visualizing, I think I'm just going to use this. So you see, you can just do what you gotta do. So let me open up the Wikipedia selection sort, explain it one more time, and then do it, implement it. Oh, that's gigs for gigs. So how selection sort happens? You have an unsorted and a sorted list. So you go through the unsorted list, you find the minimum element, then you now put it in the first position of the sorted. Then you now remove it from the unsorted list, then you now do that again. That's for the new unsorted list. Find the minimum, place it here, remove it, do it, repeat, rinse and repeat. That's how it is. So that's what I'm going to do. Yeah. Oh, and also finding, it's not ideal finding, I discovered last time, it's not ideal finding the length of an array like this. So how it should be done, it should take, the array should take two parameters. The array itself, the function, sorry, should take two parameters, the array itself, and then the length of the array. So you come here, 1 2 3 4 5 6. So the length of this array, it has 6 elements. We just do this array and with 6 elements. So you go, then, so let me just visualize it here. So you have this array. I'm coming, 1 minute. So it has 1 2. So you have, let's say, 4, then you have 3, then let's say, okay, I have no idea why that's not working. So let's say 3, then let's say 10, then here let's say 24. Okay, you have this. So yeah, the first thing that's going to happen is this array, you will get the minimum element. So how do we know the minimum element? We don't. The best thing we can do is take the first element, which is this. Come. Take the first element, which is this, Okay, we take the first element, which is this, then we assign it to, then we assign it to the smallest. Then we go over everything on this list. That's from here to here. We go over everything on sorry about that. I am finding this software hard to use, but oh, I meant to use the pen. We go over everything and we see if there's anything smaller than this. If there's something smaller than this, then we assign it to the smallest. Then we now replace it with this element, which is currently our I. Yeah. Then we repeat. So I'm coming. No. Then we repeat. So then this is the second step. So for the second step, we have taken this out. Then this would now be our new I. So this is currently our new I. Then we now compare it with everything in the list. We now compare it with 4 through 10. We now compare it. It will be our new smallest. The smallest would be this. And then if there's something smaller, then we replace it. If not, we now put it. And here we have a new list. Up here we're going to have a new list whereby we have coming 1 and then 2 will enter, and you go on and on until you're done, until your I is 0, 1, 2, 3, 4, 5, until your I is 5 or 6, however you want to do it. So how we are going to do that, our for loop, then we go for int I is equal to 0, I is less than the length, I plus plus. So now we have gotten it. Then we now say whatever is in position I, then int smallest equals to our array at position 0. We have gotten our smallest here. Then we now go. So now to know whether it is actually the smallest or not, this is before we make any, before we remove it from the list or anything. So we now check, is it our smallest? How do you do that? A second for loop for int j is equal to I plus 1, because we are going to, if our I is 0, that means then j is going to start at position 1. If our I is 1, j is going to start at position 2. Then j should be less than the length, then j plus plus. And then we go, if whatever is at that position on j, in j, sorry, so if array j is less than smallest, if it is less than smallest, then we have gotten a new smallest. So what we do, then we go smallest is equal to array j. So that's our new smallest. So it goes, then let's assume we have a new smallest, then it goes through the loop again, it now checks. So once everything is done and you have gotten your smallest, and you have gotten your smallest, then you come here. So if you go through it and if you go through the array and you find your smallest, so for this, for the first one is 1, then your the leftmost would be equals 1. Leftmost would be equal to 1. Okay, I am thinking. Give me a minute. Sorry, here it's meant to be at I. So if you have gotten your smallest, then you now do array at I should be equal to whatever your smallest is. Wait, I think if you have a new smallest, no, that's not it. So if you have gotten your smallest, then you now swap it with whatever is in position the leftmost. So on here, what is the leftmost? That's array at I. That's the leftmost. You now swap it with, yeah, that's how it is. So here you go. Array at I would be equal to smallest. But then where did we get the smallest from? Array of j. So maybe this should go in here. Array of I is equal to smallest, and then then we first go the temporary would be equal to array of j. Yeah, sorry, array of I. Array of I, Then your new array of I would be equal to smallest. Then array of j would be equal to temp. Okay, would this work? There's only one way to find out. So we go there, print the whole array. Print the whole array. So let me create the executable. Wow. That definitely did not work. Definitely did not work. 3D. I think this is supposed to be outside. But here, since we don't know what our array of j is, we can just do int s, which stands for smallest. Then here we can assign int s to be equal to whatever array of j then you can just do sorry, no, array. I am just trying things out because it seems I'm still having problem with this. I thought I understood it. What is this segmentation error? This should work. So let me go at it one at a time. So we start with our whatever is at position I would be our smallest. So here we did smallest is equal to array at position R. Then we now look from I plus 1 up to this. So you now go from I plus 1 up to this. Then if any of these elements is equal to is less than this, we assign smallest to be it. So we go if array of j is less than, so we know nothing is less than that. Then we continue if nothing is less than that. The problem with this is, what if that number is really the smallest? This would hit, and that's bad. So I'm coming 3dd. I think this is much better. So since 1 is really the smallest, I think we are supposed to do, I think I'm supposed to have like leftmost is equal to 0 here. Leftmost is equal to 0. So we just do, if we have gotten our smallest, whether we have gotten it or not, then we just do array leftmost is equal to smallest. That will now increment leftmost by 1. Array of leftmost is equal to smallest. Wait, let me run this and see what happens. Why do I keep getting this segmentation error? Main.c. Come on. I'm coming. Let me just. And I won't see whether. Let me try printing and see whether I still get the segmentation error. Main.c. Okay, it works. So it has something to do with the function. I just want to see the error disappear. This is a number, it's supposed to print a number, an integer, which is d. Fine, so where's the problem? Charge. So let me try this fix. Char star v. Hopefully it works. Okay. It doesn't seem to work. The main function should be int main. Let me see whether it works up to this line. it doesn't work. Okay. Okay, my bubble function works. Okay, something is wrong with this selection. Oh, wait. Maybe it's this number. Oh, so let me try it. I pray that's the problem. No. I'm trying to compare it with this. What could be the problem? Okay, I'm coming. Let me just delete everything here and see if it works. Just printing the array. Okay, that works. So we know inside our function there is a problem. Wait, I think I know where the problem is. Let me just add something here. If I is equal to 5, let me just break out of everything. Let me see whether that works. Now, what I'm thinking the problem is, because here I say j is equal to I plus 1, so since I can go up to 5, and 5 plus 1 is 6, so if j is equal to 6, what? Look at this. Could that be the problem? Why am I just not seeing that? That's the problem. Okay, that's good. So at least so here maybe we get a temp, then I can just do then I can temp comma idx to store the index of whatever our smallest is here. I can just do the index of our smallest would be equal to j. Okay, so you have the index of the smallest. So here down here you swap whatever the smallest is. Okay, in case this doesn't hit, I also need to do index up here would be equal to I. Yes, so in case that doesn't hit, then we come here and do. So my temp would be equal to array at I, then array at whatever index, sorry, that's supposed to be idx, would be equal to smallest, like this. Hold up, hold up, hold up. No, something is wrong here. Array at your whatever the current is, the index is. No, it's not supposed to be smallest. Array at I. At let me see what this does, because I don't even know what I am doing. One, two, did it work? What? Shock of the century. Let me try it out. So we just do, then we just do 43, then we just do 22, then we just do 18. So we have 9 elements. 9 elements. So our length would be equal to 9. So let's run this and see. 1 2 5 7 8 10. Can you see that? 1 2 3 4 5 6 7 8 9. It worked. So this is power. This wasn't what I even saw. This wasn't what I saw on Wikipedia. This wasn't their solution. I think I have redundant elements in there. But if it works, don't touch it. Right? So that's it for this one. So next we go to insertion sort. Insertion sort is a simple algorithm that builds the final sorted array one item at a time by comparison. So what's the difference between insertion and selection? Or did I just do insertion? No, I don't think so. Let me see. Insertion sorts. It reads consuming one input element each repetition and grows a sorted output list. At each iteration, insertion sort removes one element from the input data, finds the location it belongs within the list, and inserts it there. What? Let this come back to the beginning. So it keeps going. What? I don't think I know. I still understand how it works. Sorting is typically done in place. by iterating up the array, growing the sorted list behind it. Oh, I see. So let me remove this, remove this, remove this, remove this, remove this, remove this. Okay, so I think how it goes is it starts from here. It starts from here. It checks, is it sorted? Okay, it's sorted. Is it sorted? It's sorted. Is it sorted? Sorted. How it knows whether it is sorted is it just said it checks, is this greater than this? If it is not, that means it is sorted. Okay, is this greater than this? Sorted. Is this greater than this? Sorted. Is this greater than this? Yes, it is. So now it is going to take this tree and insert it where it should go within this sorted list. Well, how does it know where the tree should go? Maybe it tracks back. 3 is less than this, fine. 3 is less than this, fine. 3 is less than this. No. Then now puts it after this. Sorting is typically done in place by iterating up the array, growing to the sorted list behind it. At each array position, it checks the value there against the largest value in the sorted list, which happens to be next to it in the previous array position checked. If larger, it leaves the element in place and moves it. If smaller, it finds the correct position within the sorted list, shifts up the larger values up to make a space and inserts it. I think I understand how it works, just like I explained here. So it checks, and since this is currently at, let's say, this number 3 is currently at a A4, but we know A4 is less than A3. So we now swap them. Then you now check if if A3, after you make the swap, you now check if A3 is less than A2. If it is less than, you swap. If it is greater than, then you just continue from where you stopped. Yeah, let me see if I can do it. So we have int length is equal to 9. Length is equal to 9. Let me just get this since it's the same. Okay, we check. Okay, instead of finding the smallest for this one, we are going to find the largest. So we can go largest, the number array at 0, that's the largest. Then we now enter a nested for loop, and this one we're going to find if they are smaller numbers than this. If they are smaller numbers, then we now shift them backwards. Yeah. J is equal to whatever y is plus 1, then j also less than length, j plus plus, then we go if, then let's see, if whatever is there at j, if it is less than the largest, I am coming. So we go 1 is the largest, then we now move. If whatever is here is greater than 1, it should be our new largest. I think I should do it like that. Is greater than 1, then we go largest to be equal to our number array at j is greater than, then we now move to the next one. 4 is greater than 2, largest, then 4 is greater than 24, 24 is our new largest, then if 3 is greater than, okay, 3 is not greater than 24, so what happens here? So we'll get an else. That's if the number is less than, okay, we know 3 is less than 24, then how do we go about that? Then we swap the position of 3 and 24. Would that work? Swap the position of 3 and 24, and we go int temp is equal to at 3, then the number where 3 is would be equal to the largest, then would be, so here would be where our largest was. So, and how do we know d? So we can just come here and do LIDX, which is our large index. So we can just do LIDX to be equal to I. So inside here we'll do LIDX to be equal to J. So we do of LIDX. So let me do this and see. So let me run it. 1 5 2 7 8 10. Somehow 43 got repeated twice. Okay, it did not work. 5, 2 and 7 were swapped. Okay. Let me just so that we can see the numbers. So 2 and 7 were swapped because they met the condition. 1, 5, 2 and 7 swapped, 8 and 10 swapped, 43 moved to the end, 22 and 18. This is bad. So let's see. Let me just see if I can get a better explanation. Insertion sort is a simple algorithm that considers one element at a time in an array of data and moves the item into its correct position, shifting all other elements along as it does so. Consider the list above. It is an array of 8 elements and we wish to sort it into us. Starting with the second item, we ask, is this value less than the previous value? If the answer is no, then no action is taken. However, if the answer is yes, then we iterate through all of the values before that until we find the correct location for it. Okay. Okay, I think, let me see. So let me see. So we check if the position is less than whatever our largest is. Wait, I'm coming. I think I made a mistake. Here should be I. Let me run this again and see. You never know. Maybe I did get it. Did I actually get it? But then where is my 22? Somewhere along the way 22 disappears. I don't think this is the algorithm though. I don't think this is it though. We check if it is less than. Is it less than? All we know is that if it is not less than, then we have a new largest, whatever is there at J, then LIDX would be equal to J. So but what happens if it is less than? If it is less than, then we loop through the items you have done and find the right position. Yeah, that's what it says. then we go for int. Okay, is equals to what though? Whatever our I is, because we are starting we are going to loop. We are going, so let me show you. Let's assume we are right here, so we have to loop through this for, and what is that? This is our I. No, are we sure? No, it's supposed to be 0. We loop from the beginning, but where do we stop? I is less than. So let's say we are here and this is our j, so we are going to loop from I to I plus 1, from I to j minus 1. Yeah, I think that is it. J plus plus, then we go if whatever is at position k, that's the first element, is whatever is at position k is less than what our j is, which is this. We continue, else we swap them. So we go I have no idea what I'm doing, but then if it works, then I will know what I'm doing there. So we go, our temporary would be our number at position j, because we are going to swap whatever. I'm coming. So if we loop through this and we see that is what so this is our k, so is this less than this? No, we continue. Is this less than this? No, we continue. Is this less than this? Yes. We're not supposed to swipe it. We just put this in a temporary variable, then we swap. So we go would be equal to okay, but then what about this for? So let's store it in a temporary variable. Temp would be equal to j. Okay, but then how do we assign it? Temp would be equal to j, and then do we go am I supposed to do something like int current is equal to, no, that wouldn't work. But then if I do, let me just 5 7 5 10 8 4. Then do we go, if you have our temporary to equals to G, do we swap them? It's K temporary. What happens then? 1 2 7 5 10. So 1 2. It did not work because it swapped 2 and 5. It swapped 2 and 5, but then it didn't know what to do next. Then 8. If our current is less than that, then we continue. If it is not less than, we put it there. And then how do we do about? Let me see how this works. Oh, I see. So instead of swapping here, we just know that this. So this is it. Wow, it looks so simple. I is less than the length plus I. Your key is that greater than key to one position ahead. Then J is I minus 1. J is greater than or equal to 0 and is greater than key. Well, let me do that and let me use that and see. let me see how it works. So you look through your array. Your J is, so first your key would be, oh god, wait. So if you have this, when you start, your key would be this. This is your key, and then this is your J. I minus 1. J is I minus 1. Then while J is greater than or equals 0. So while J is greater, and array of J is greater than key. So this, while this is greater than 0 and whatever is here, while this position, sorry, is greater than 0 and whatever is here is greater than whatever is here. So while this is greater than 0 and 1 is greater than 2. So since this is the case, then you go array J plus 1. So J would be equal to 0. Then plus 1, 2 is equal to 2. And this would be equal to 2. And then since we have array J plus 1, which is at this point array of 1, which is the second element, is equal to array of J is equal to J minus 1. Okay, very complicated, but okay, this is it. Current element is 23. The first element is assumed to be sorted. The sorted path until 0th index is 23. First pass, compare 1 and 23. Since 1 is smaller, insert 1 before 23. So first is 1, 23. Okay. So that's that for today, and I will see you in the next episode. I hate sorting, man. What? I hate it. But then, so see you. Bye. I am tired.